So the topic of the panel today is decentralized science and challenges and opportunities in decentralized science. So I'm a bit older than you, so I'm actually, my background as a scientist, I work at CERN in Geneva for 30 years. And this is the biggest scientific lab in the world. And this is an interesting, and we will discuss during our discussion about it as well. So this is, in the same time, the most centralized part of science and the most decentralized part of science. So the centralized is that our big experiment is actually at CERN in Geneva, and you had to come there to make an experiment. But we were 10,000, and we are now, at this moment, 10,000 scientists which are distributed all over the world, using the experiment and analyzing data by sitting in their institutions at their homes. And 30 years ago, there was one of our colleagues who was a physicist and a computer engineer at the same time. And his boss actually gave him a task to develop a tool by which we will communicate all over the world. And we were just maybe 1,000 of us at that moment. And that guy, whose name is Thomas Berners-Lee, he invented the World Wide Web. And he made the world decentralized today. And now we have Web 3.0 that you will talk about a little bit. And by the fact that that was invented by the public lab, it became the public technology. At the same time, there was a similar technology in France. I don't know if you, but you don't remember, you are not that old. It was Transiscans.
Yes, rather
yes. Minitel. That was about a similar technology, but that was developed by the company. And that technology did not spread over the world. It was the World Wide Web who won. And the fact is why it won actually because it was financed by the public money, and then it made the world really decentralized. So the CERN is an example of the lab which is centralized and decentralized at the same time. But I would then maybe start with Joshua, maybe with you, since you are the co-founder of the DeSciWorld, and maybe you are the best person to give us a little bit more the overview of what are the biggest challenges and the opportunities in decentralized science. Just thank you.
Sure. So decentralized science is essentially using the Web3 blockchain infrastructure to change or improve science as we know it, right? And along with finance, with DeFi, and many other aspects of blockchain technology, the improvements that blockchain can bring are pretty wide-ranging. DeSci has probably the highest stakes in terms of this improvement. We've got, research, data, sensitive data. The progress of humanity generally will be, yes, funded by DeFi, but the progress will happen in science, or in this new paradigm, potentially DeSci. So the opportunities are massive in terms of organization, in terms of changing the incentive systems. How can a scientist decide to do research and get money for doing so, right? How can you improve your possibilities to do research from your hometown rather than from traveling all over the world to do things in Harvard or etc.? So the decentralization aspect that was mentioned here about CERN, that can also be improved even further by having the equipment itself being decentralized around the world rather than just being concentrated in a single point. If you can imagine, finance itself can be the opportunities that come with decentralized finance, with putting the sovereign ownership of your own assets back into the hands of the people. Imagine the potential for doing so, but with research, with knowledge, with data, with the equipment that you can do research with. Some of the opportunities that are being presented to DeSci right now should, if we do a good job, should lead to a fundamental re-understanding of science akin to the Enlightenment era a few hundred years ago, right? The potential for DeSci to really change what science means and how people interact with knowledge, with each other, with the world around us is huge. The challenges are also likewise pretty big. DeFi has its own challenges in terms of understanding, adoption, regulatory compliance. These are big issues which underpin the entire framework of blockchain and Web3 right now. But the stakes are much higher in science. If you can imagine sensitive data being put on a ubiquitous blockchain, for example, you can see the issues here. Or how do you police or regulate access to equipment? How do you police or regulate access to the fundamental nuclear codes, these sorts of things? Like when talking about like germ warfare, these sorts of things. When this data is stored on an open source blockchain, how do you police that? So the challenges and the threats of DeSci are massive. It's not just about how do we use the blockchain to improve our scientific endeavors. It's how do we understand what it means to have ownership over research data, ownership over or sovereign access to these equipments, to the fundamental building blocks of science. Because right now it's pretty walled, and that helps, but also that hinders progress, hinders equitability. So these are some of the biggest problems, I would say.
Yes, thank you. I see some other problems, but we will come to that later. So, Sarah, during my career, I had many questions of the type, why are we financing this? Because the particle physics is all about the beginning of the universe, when the universe really started. And to be honest, there is no any use of it. We will never use the Higgs boson, I think, in our technology. Although you should never say never, because there were some people saying never for some other things. But I'm pretty sure about the Higgs boson. And then people were asking, why do we finance this? What's about, and this is actually costly science. It costs billions of euros and dollars. And I guess that this is the same for the space technology as well. But we know why we are financing. So I will just ask you, what are the connections about these space flight technologies and the benefit of the humankind, and how decentralized science can help in that respect?
Okay, yeah. Could I just ask first, how many of you are scientists? Are any of you here? Not a few? Not many, okay. Yeah, so this kind of question of how we value research is, that's a bigger question, not just part of DeSci. Maybe some of you are aware or not, but there have been recent studies saying that there's been like decline in impact in research papers. And this is partly down to how science is incentivized and how scientists are rewarded, which is mostly right now by publishing like small incremental advances. So I think one of the ways DeSci can change that and impact it is by changing the incentives, as Joshua mentioned. So part of that is how we fund research, and also bringing in other communities like closer to the cause. So a lot of the DAOs that have been built, so decentralized autonomous organizations, the autonomous part is not really there yet, I would say, but basically trying to move towards building really decentralized communities where people can be rewarded for contributing to the DAO. So that could be by sourcing projects or by voting or peer reviewing them, these kind of approaches. And what we're really trying to do at SpaceBioDAO is make space research more accessible to scientists globally. So right now, there are many scientists who should be sending their research into space, but the kind of barriers of doing that are really high. So there's a lot of paperwork, and yeah, we're really trying to lower the barrier for that. And then in terms of how this can benefit humankind very directly, but maybe a bit longer term, I'll talk more about it tomorrow, but really the kind of advances we need to make to be able to send these automated tiny experiments into space. So they need to be very lightweight, very efficient, so no waste, very light. And also we need to be able to miniaturize everything and analyze things in real time, because the chances of biological samples making it back to Earth from space are not very good. And particularly once we talk about going into deep space, so past the ISS, where we really understand more about the impact of deep space on human biology. So those are some of the challenges that are really going to lead to advances here on Earth. So we'll be developing, new ways to analyze these experiments and new tools even to run them. So as we move more towards biology being very data-driven and automated, I think that that's where it will directly contribute. And then aside from our project, there are many different DAOs that are aligned on, say, rare disease, so people can really invest in those as well. Yeah, maybe that's a good point to stop, actually, in case.
Yeah, thank you. Andre, you are actually, there was a last minute change in the, so you are new, so I didn't have a chance to know you. So maybe I would ask you to say a few words about yourself and your company, and then how it is connected with the DeSci.
Yeah, sure. So yeah, my company is Landrain Protocol. So basically, we create decentralized platforms and ecosystems where patients, alongside scientists and others, can tackle unmet needs in healthcare. And the reason why we've started this is because the incentives within the traditional health and scientific establishment don't always align with patient outcomes. So with pharma, they're very profit-driven, which is understandable. They're a private business. But that sometimes comes at the expense of finding treatments that are actually effective for patients. And in academia, there's an incentive to publish papers and kind of develop a basic knowledge, which again is very important. But very little of that actually translates to an actual end product which can cure patients. And in essence, what we're trying to do is inject the drive and the skin in the game that patients bring who want to get cured and get better, to really drive research and really hone in on what actually matters. And we have a lot of examples of rare diseases, as was mentioned, but also in the diabetes space, where there's an online open source movement of diabetes patients who came together to develop a new device and software, which the industry wasn't offering because they couldn't wait and they were struggling with managing diabetes. And that ultimately became the standard of care and is now driving I think it's like a $10 billion insulin devices market. But whilst that improved outcomes and has actually provided economic value to companies, that wasn't initiated by patients, by the companies, but it was by patients, because what the industry was offering wasn't suiting their needs, and they did it out of necessity. So yeah, I think in essence, DeSci provides the opportunity for patients to come together in a more systematic and organized way through DAOs, but also provides them an alternative funding source to actually drive the priorities that they have, because typically you rely on kind of grants from the NIH in America or from private industry to kind of get cures to market. So those are the kind of main funding sources, but ultimately blockchain and DAOs provides a alternative funding source which can be driven by the end user in collaboration with scientists. And I think we can get better therapies and devices, etc., and better outcomes as a result.
Okay, thank you. And Thomas, you are co-founder and president of something which is called Just One Giant Lab. So I work at CERN, which is the biggest lab in the world, and yours is actually even larger than CERN. So what it is? So are you centralizing science by making one giant big lab?
Yeah. Hi, everyone. The story behind the name is to say, if we all humanity come together in one single laboratory, there is no problem we cannot solve. So our goal with Just One Giant Lab, or JOGO, is to connect all the research and innovation ecosystems on the planet, be it research institutes or NGOs or DAOs. It doesn't matter, as long as you have people that wants to contribute on producing knowledge and creating tools to solve problems, basically. And so when you are in the world of research or even innovation, most of the time people act in their own professional networks, right? So, and when you're, especially in your youth, when you're starting, it can be very hard actually for you to realize with whom you should collaborate, what are the projects that could be relevant for you. Sometimes you have to wait years in order to understand that somebody was working on something interesting for you and right in the next door, because you have to wait for them to publish. Right, and the publication cycle can be extremely long, but it doesn't prevent you from sharing as a scientist what you're working on, right? And you could start sharing some even data or results with a network of people. So it's very relevant for CERN is all about this, right? Is how do we connect the right physicians together and engineers so that we can have a higher critical mass of collective intelligence, and so. they do that not only in a centralized manner, as you said, but they have this network of scientists, and you have to use tools to connect all these people together. But what about providing this kind of infrastructure to any organizations, any infrastructures, any networks, on the planet? And so you start. We're working with universities, we're working with research institutes, we're working with R&D companies, because they all have the same needs: is how do I provide more value to my ecosystem by first understanding them better, so I can see what's going on, the kind of collaboration that is happening, but also by making them self-organize, right? Because finally they can understand who is doing what, and they can self-organize in communities, in projects. I can start also in bringing from the outside people who are not the usual suspects, so not only scientists, like patients, like Andre is doing. You can have civil servants. We work with public agencies as well. So we all have this in common, that at the end we want to do projects together. But we all live in silos, and so we want to break those silos. And then DeSci comes in the sense that we want to be able to not only support traditional organizations, but also decentralized organizations, decentralized communities. And so we see a lot of potential in these decentralized DAOs, right? In the DeSci DAOs, and we want to be able to have them also connected to the traditional worlds, so that these two worlds can get connected. And if you're a scientist working in a one institution, you can jump, also in the DeSci DAO, very easily and back and forth, right? And so this way, it means that they will be helping the emergence of these new kind of entities, their growth, their funding, right? This is what is very exciting for us. And so at the end, what we hope is to have millions, of contributors on the platform, and at the end, even have communities on Jogo that will have more funding than normal institutions, because they will be more efficient at allocating them. Right? I think you can trust better. Now imagine it, I don't know how it works exactly in CERN, but for the funding allocation, I guess it's through grants and peer review. It's an okay system, but it's kind of it's like a black box sometimes. And it's very criticized by scientists sometimes, especially for great agency. Imagine if it was the scientists themselves deciding how to allocate the most efficiently the resources according to the ideas that are coming up, but in a much more agile way, right? Because you don't have, if your project is interesting, but it doesn't make it for some reason, you don't get the grant, you have to wait sometimes 1 year to try again, right? So the idea is you want to be able to provide support even to the smallest ideas, maybe with a smaller amount of budget, but to be much more agile in that way. And we've tested that many times, especially during COVID, for example, with great results. And now we want to be able to help other research innovation organizations to do the same.
Yeah, thank you. So the CERN is actually financed in a simple way. Governments are financing this, and this is pretty much centralized. But it works there because it's a long-term science. We have to plan for next 30, 50 years, and we have to have a stable financing system. Of course, there are smaller projects which are financed in a different way. But at CERN, for example, we introduce Archive, which is a publication system in which you first publish at Archive, then you send it for the peer review, and while the peer review is completed, you already see whether this paper is actually of a good quality, whether it was cited or read by the others, and then by the publication, actually already know whether the paper is successful or not. Of course, there are disadvantages of that as well, but this we introduced, and I think now it's used in many domains of science. But so, Joshua, one thing that it is actually worrying me a little bit. So when I read about DeSci, there are keyword is democratization of science, and I'm wondering whether the word democracy is really relevant to science. Because we cannot vote whether the scientific result is about the scientific idea. Maybe the better word is meritocracy, not democracy. So how does it actually work with this democratization and the DeSci? What do you think about democracy versus meritocracy in this world?
Yeah, so as a scientist, I'm sure you have an opinion that is different to others, right? Because you see, internally, you see the dangers that can be given with democratic access to lab equipments and to sort of certain data, certain knowledge. This should be, from your perspective, walled behind certain checks, certain balances, because people need to be qualified to handle these things or qualified to access these data sources. Now, if you read that from our website, which I think you may have done, the democratization of science in this sense specifically, probably should clarify, refers to the democratization of the access of knowledge and the equitability of knowledge, equitability of having the ability to see under the cover of what science is being, what is being done in science. And for example, during the COVID crisis we had, a lot of science was put in front of people, right? But it was post-production science put in front of the mass of the population. And people were, for the first time in many people's lives, given the sort of incentive to say, I might question this, or I might have an interest in seeing what's going on here. And that put up a lot of barriers in front of people to do so. Whether or not you believe one thing or another in this situation is kind of irrelevant. The point being that having that access to the knowledge, having that access to, for example, the provenance trail of research, right? Understanding where the research was done, what data points were used, what algorithms were used, which scientists contributed, where their funding came from, who benefits from the funding outcomes of some of these sciences. These are all very important factors, and when I say the democratization of science, I suppose I should clarify, but that is more what I'm referring to. When you look at science in the sense of who should get access to things, right, to equipment and things like this, of course there should be much more stringent checks and balances involved in, for example, accessing equipment. Or it then becomes this fine line of what about data? Okay, so there's some proponents for the data lake. Now the data lake is this concept of everything open source all the time, and the portals to that data, to that lake that allow you to access it, that could be where there might have some checks and balances. But there should exist in this idea a fully open source lake of data for all data, so knowledge is not siloed. This is fraught with its own issues in terms of how do you gain incentives for the work, how do you stop terrorism, etc., etc. But this is a debate that's happening right now. Access to equipment, real world equipment that you can then turn that data into to weapons or to medicines or whatever, that costs a lot of money. The material value of that does need to be allocated much more efficiently than democratization, so meritocracy is obviously the best way to do this, especially in science. But it is, as I said at the beginning, DeSci, one of the opportunities is a fundamental re-understanding of what it means to be a scientist, right, and to do science, akin to the Enlightenment era. The Enlightenment era distributed access to knowledge and science to everybody, which is why we moved so quickly in that period of time. If DeSci has a similar effect, the opportunities are massive, but the threats are very real. How do we police? How do we check? How do we balance having access to this data? It's an open question, and I completely agree that, for example, sensitive data points or impactful equipment and these things should be governed meritocratically, but it will be a direction that moves towards open access, and there will be stages at which some things will open up, for example, data, and other things such as equipment will take its time.
Okay, so it's a democratization of access to data rather than to listening everyone's opinion about certain aspects. Because I'm a little bit worrying in the sense that maybe to send the wrong message, the science is easy and everybody can be a scientist. Actually, to be a scientist, you have to study a lot, and it's not easy. And one thing which I'm pretty optimistic guy, and I think that there is nothing wrong with science for the moment, and it was developed perfectly during the last few hundred years, and this is why the whole humanity is now in the best shape ever. So we don't need fundamental changes, we just need changes, like changes are everywhere. But I think there is nothing wrong with science. The only thing is that maybe in this modern world in which we are, maybe the confidence of people in science may be decreasing a little bit, but this is also questionable. And somebody said, I think that you, Sarah, said that maybe we are investing less money in science. Or no, I read it on the web page of the DeSci, which is, I think, not true. We are investing more money in science, and which is a right way of doing it.
The amount of money in science is increasing, but the amount of money in the system in general has increased massively. So the amount of the numbers on the screen are kind of irrelevant because they're always increasing, hence inflation and other things. It's the impact of science and the distribution of that science. For example, patient-focused care is reducing. The reproducibility crisis has caused about 20 to 30 years, et cetera, et cetera. So the money in it, the funding in it, yes, the progress is still increasing. We're getting nice new flashy toys, but the rate of progress is declining. The access to that funding and the profitability, the margins on science are increasing massively, which shows an inefficiency in allocation towards science rather, against science rather towards profitability, which is an inherent issue to science right now. The scientific method, sure, of course, do not mess with that. But the scientific paradigm as it exists right now is very corporate, and it pushes a lot of resources to inefficient places such as the back pockets of people who don't need it.
Yeah. Well, we are all owning these these multinational companies. We are owners of these multinational companies through our shares, so we are all participating in this. You are not. I am the owner of Apple, for example. No, I'm kidding. So we already have some examples of this decentralized science in the past. We started with SETI at home. Then there was a protein folding and all this. So do you know, I don't know, I didn't actually study this. What are the outcomes of these projects? Did people really participate and at which extent? And was it positive experience or negative? I don't know if you have some experience with that.
Yeah, I'm not sure if everyone's familiar with this concept. There was, I don't know, a good few years ago now, something called Fold It, where they tried to get the public to run this program on their screensavers when they weren't using their PCs. And I'm not sure if you've heard of this or not. And more recent examples since then. So basically citizen science. I'm trying to solve problems that no one had managed to solve in-house for a long time. I think that overall, I guess there was a positive impact from that. It raised awareness. It's pretty hard to measure those numbers. I guess the biggest kind of impact we've had recently, as Joshua mentioned, is COVID. And suddenly, I can see from my work at Imperial, we suddenly get more applications for people who now think science is cool and they want to be scientists and work in biotech and solve these problems. But yeah, I think kind of coming back to what you were saying about, science is hard. But I think what we want, or I would just speak for myself, what I would like to see is that science is hard, but I think it's becoming more accessible to become a scientist. And we just want to make sure that people everywhere have the opportunity to enter science rather than, yes, you need to train, but I think even the way we educate scientists now is changing. People are less interested in staying in academia and more interested in industry. And I think we have no idea in 20 years how it's going to look, how we educate our scientists. And that's one way where I think this concept of Joggle or decentralized labs, decentralized PhDs are going to become quite impactful, I hope, in a positive way.
Yeah.
I'd love to add on this. It's true that we actually have a lot of scientists, but when you think about it, a scientific project doesn't necessarily need only scientists to work on it. Sometimes you need just data scientists. You need some engineers. You need to work with patients. And so when you look at some of the most impactful work that can really translate into real life applications, you really have this diversity of contributors that are at the core of it. Too many scientific projects remain in the lab for these reasons because they were just conceived by scientists, which are somehow, in the ivory tower sometimes. and they're not concerned by the translation into the real world. And so the point is, how do we, right now, when you look at academic institutions, they're too isolated, right? They're too siloed. And so there is right now, in order for making science more efficient, right? So making more with less, in a sense. It's all about making sure that people from outside academic institutions can really participate at the right level and the right position. So being able to work, for example, we did programs at Jogo where we had data scientists working in banks, but applying their skills on algorithm to monitor cancer rate, in the global population. It's the same kind of tooling, right? It's data science, but the kind of data scientists that banks are much more skilled sometimes because they're way more paid, right? And so it's a question of a job market than the one that academia can afford. And so being able to bridge these kind of populations and support scientific project this way, I think is very relevant as well.
Yeah, the big advantage of this I see exactly in what you were talking about is to bring more people to science and to participate at a certain extent, not at the expert level. We don't expect people that they will, but even if they participate in sharing data, sharing their resources, they become a part of the scientific world, which is very good for the modern society. Andre, one of the biggest problems that Joshua mentioned is the reproducibility of scientific data, particularly in the medicine. In particle physics, that's maybe easier, but in medicine, this is becoming a big problem. And how DeSci can help in this respect?
Yes, I think with peer review in general, a lot of it's voluntary time, and I think there was a study about like the actual value which is created by peer review as being in the billions, and yet people are doing this for free. So I think if you have some kind of financial incentives that will draw more peer reviewers, and I think will have an impact on the quality of that. But also, I think because there's a more decentralized system and there's more eyes on the data, you'll have more eyes and you'll be more likely to basically spot any errors in the data and flag those. I think if you have like 10,000 people, for example, having eyes on a piece of data, you're likely to find more issues with it if it was just compared to like 5 people looking at the data. So I think it tackles the peer review because it's more transparent in how the data was formulated and how it came about. But I think also with the addition of incentives to encourage more peer review and bringing more people into it, I think it will have an impact in that respect as well.
And we are at the end of our time slot, so I will just give you 1 minute each to tell us what do you think about the future of this decentralized science? How do you see it?
Well, for me, it's the end goal of science, right? It's where you can be at any point of your life if you want to find a way to contribute to the advancement of knowledge, which is one of the highest, achievements that humans can do. You'll be able to do it, right? And if you need to learn, well, you'll find the right resources to learn, get on skills, and actually contribute on the problem that really matters to you. So it's kind of like entrepreneurship spirit, but for science, right? So we need to find and build the right infrastructure for this, because the current world of science is too much built on foundations that were made in the 20th century when the internet was not there. CERN was a pioneer, with archive, with the web, but now we have even more advanced infrastructures, and we need to adapt, and we need to help these institutions to get into these new waves as well.
Yes, so the question was around the future for DeSci. What's the... Yeah, so I think basically a lot of what Thomas said, really just building the infrastructure to bring more people in, because there's a lot of expertise which can help, really enhance and hone in on what actually matters in the medical sciences in a way that doesn't happen. And I think if we can bring in more patients or more citizen scientists or independent scientists in that process and rewarding them for doing so, but also providing the infrastructure to allow them to do really groundbreaking stuff outside of the traditional system, I think will really advance science in a way that we haven't seen before. Because even Freeman Dyson, I know he passed away, but he predicted in 2012 that in the same way that the internet was democratized and led to a massive level of innovation, which John von Neumann didn't actually think would happen, but it did. Freeman Dyson also predicts that that'll be the same process within the medical sciences. And I think if we can replicate that success of the internet and what that's brought the world in the medical sciences, we'll be in a very good place. And I think DeSci is the way to do it.
Okay, they've said a lot already, but yeah, I think the thing to note is that with DeSci, we're still very early. It's only been maybe a couple of years since it's been called that. Jogger's been around longer than this. But yeah, hopefully, yeah, continuing to build. And again, as I said, I think it's really important that we can make science more global, meaning that, you know, your passport isn't going to define whether or not you have these opportunities in science. So I think that's one big area where we can contribute with DeSci.
Thanks. I think that, as mentioned, the entrepreneur scientist here is going to be the big change. You're going to be able to be rewarded for your science that you're producing, but not just in a sense of what is required by current systems, current narratives, etc. It's what you are passionate about, because you are able to create the incentives for your science much more effectively. And this passion-led research, I think, will lead invariably to this new scientific paradigm where we are much more wise in the science that we do. We consider humanity, we consider the things that we don't quite understand yet in a much more applied manner. Because right now, there's things we don't understand, and we try to explain with things in the methods that we do understand. And I believe that DeSci will create a much more open and wise version of science.
Well, thank you very much. So let us thank our friends and colleagues. Well, I forgot to say something at the beginning. So welcome to Split for all of you who are outside Split. Split is the most beautiful city in the world, and this is the objective statement. So please enjoy Split and come back, and repeatedly come back like Thomas. He was here 4 years ago, and then now he's here again. So you're always welcome here to Split. And I invite you to participate in science, and for that, I suggest you to learn statistics and probability. These are the most important skills for the future. So thank you again, and enjoy Split. Yes.